Hey guys, today let's combine the effects of A, H, and K. Here's today's FLT. Given different types of functions, I will be able to identify the effects of A, H, and K by describing, sketching, or defining the function. So far, we've learned about the effects of the different parameters A, H, and K. Today, we're going to combine these effects. So before we look at examples, let's look at what each parameter tells us. So here I have a quadratic function, y equals a times x minus h quantity squared plus k. A tells us two things. It gives us the dilation, so whether there's a vertical stretch or a shrink. It tells us whether the parabola will become wider or narrower. So there's a vertical stretch if the absolute value of A is larger than 1. And there's a vertical shrink if the absolute value of A is less than 1, so something like 0.4. So A tells us about the dilation, but it also tells us whether or not the parabola will be reflected. So if A is negative, there's a reflection across the x-axis. We flip the parabola. Next, let's look at H. So what does the parameter H tell us? H gives us the horizontal translation, so whether we'd move left or right. We translate the function to the left if H is negative, and to the right if H is positive. And lastly, what does the parameter K tell us? So K gives us our vertical translation, so whether we'd move up or down. Translate the function down if K is negative, and move upwards if K is positive. So this was just a quick summary of the effects of our parameters A, H, and K. Now let's take a look at some examples where we will have combined transformations. So for our first example, let's describe and sketch the transformation of this function. Y equals 2 times x minus 3 quantity squared plus 1. My first step is going to be identifying A, H, and K. We can do this easily by writing out the general form with parameters A, H, and K. So we have y equals A times x minus h quantity squared plus k. We have an exact match, so we can easily identify A, H, and K. So in this case, A is replaced by 2, so A equals 2. Let me write that on the side here. And then H is replaced by 3, so H equals 3. And then we also have K replaced by 1, so K equals 1. So we've identified A, H, and K. Now let's think about what each parameter tells us. So like, what does A tell us, what does H tell us, and what does K tell us? So we know that it's going to be a parabola since it's a quadratic function. So we have a parabola that has and then let's think of the effects. A equals 2, and 2 is greater than 1, so we have a vertical stretch. Notice in this case we don't have a reflection since A is positive. So A tells us that we have a vertical stretch. And then we also have some translations. So moving left or right or up and down, we're shifting the parabola. H and K will tell us how to shift that parabola. So far we have a parabola that has a vertical stretch and a translation. Let's first look at H. Since it's positive, we're moving 3 units to the right. So we're moving 3 units to the right. And also, let's look at K. Since K is positive 1, we're moving up 1 unit. So 1 unit upward. So we have a parabola that has a vertical stretch and a translation 3 units to the right and 1 unit upwards. So we provided a description. Now let's provide the sketch. So remember, your sketch doesn't have to be exact. It's just more to get like the general idea of what our parabola would look like. So here's our parent function, and we'd move 3 units to the right, 1 unit upwards. And remember, it's going to look narrower because we have a vertical stretch. So our parabola would look something like this. For our next example, let's describe and sketch the transformation of the function y equals negative 0.1 times x plus 4 quantity squared minus 2. Our first step is to identify A, H, and K. So the general form is y equals A times x minus h quantity squared plus k. Notice it's not an exact match, so we're going to have to rewrite this given function. Y equals negative 0.1 and then x minus negative 4 quantity squared plus negative 2. Now we can easily identify A, H, and K. So A is replaced by negative 0.1. So A equals negative 0.1. H is replaced by negative 4. So H equals negative 4. And K is replaced by negative 2. So K equals negative 2. What does each parameter tell us? Alright, so since it's a quadratic function, we know that it's going to be a parabola. But what happens to the parabola? So first let's look at A. Notice that A is negative, so we're going to have a reflection across the x-axis. Again, because A is negative, we're going to have a reflection. And then I know I'm writing a little small here, but the absolute value of negative 0.1 is 0.1. 0.1 is smaller than 1, so we're going to have a vertical shrink. The parabola is going to be wider compared to the parent function. And then we're also going to have some translations, so shifting the parabola around. So let's look at how we translate the parabola. Since h is -4, we're going to move to the left 4 units. So translation 4 units to the left. And then let's look at k. K is -2, so we're moving down 2 units. So 2 units downwards. We have a parabola that has a reflection across the x-axis, a vertical shrink, and also a translation 4 units to the left and 2 units downwards. So let's sketch this out. Think of it kind of like a checkbox when you're making your sketch from a description. So be like, okay, so reflection across the x-axis, check that, vertical shrink, blah, blah, blah. So here I know I'm moving the parabola 4 units to the left, 2 units downwards. I also know that the parabola is going to be flipped, so that's the reflection. And there's also a vertical shrink. You can always break down the sketching as well. So for example, start off with the parent function, reflect it across the x-axis, and then make it wider because it's a vertical shrink. Then move it 4 units to the left and 2 units downwards. So on Edpuzzle, please describe the transformation of this function, y equals 0.3 times x plus 4 quantity squared plus 2. And try sketching it in your notes as well. What would the transformation look like here? What if we go the opposite way? What if we're provided the description and we have to define the function? I know there's a lot of words here, and it might seem confusing at first. You might feel like this grandma, but that's okay. Let's break it down piece by piece. So first, let me just read it. So we're going to define the function with the following description. A parabola that has a vertical dilation of 3 and a translation 2 units to the left and 4 units upwards. What is this function going to look like? Well, since it's a parabola, I know that it's going to have a certain look. So since it's a parabola, I know it'll look like y equals a times x minus h quantity squared plus k. So next, let's find what a, h, and k would be based on this description. So let's first focus on a. A talks about the reflection, which we don't have in this case, and also about the dilation. So here we have a vertical dilation of 3. So A equals 3. And then what about H? So that's the horizontal translation. So notice here 2 units to the left. Left, so negative. So H equals -2. And then for K, is there anything telling us about the vertical translation? Yes, 4 units upwards. So K will equal +4. So now I can write what the function would look like. Y equals 3 times x minus negative 2 quantity squared plus 4. I'm simply replacing the parameters a, h, and k with the values we just found. And let's rewrite this to make it look a little simpler. Y equals 3 times x plus 2, because of that double negative, quantity squared plus 4. So based off of our description, we define the function to be y equals 3 times x plus 2 quantity squared plus 4. And to see if this is correct, you can always graph it on Desmos to check your work. Notice here we do have a vertical stretch, the a equals 3, and the parabola moved 2 units to the left and 4 units upwards. For this next example, let's define the function with the following description. An absolute value function with a reflection across the x-axis and a translation 5 units to the right. Again, let's break this description down piece by piece. So we have an absolute value function. So what would that look like? Y equals a times the absolute value of x minus h, also plus k. Let's find the values for a, h, and k. For this example, for a, there's no dilation, but we do have a reflection across the x-axis. So a is going to be negative, and since there's no dilation, it's going to be negative 1. For h, we're told that we have to translate 5 units to the right. So h is going to equal positive 5. H equals 5. For k, there's no vertical translation here. We don't go up or down, so k is simply equal to 0. So let's replace the parameters with the actual values. Y equals negative 1 times the absolute value of x minus 5 plus 0. I replace the parameters with the actual numbers we found in the description. And let's write this a little simpler. Y equals negative and then absolute value of x minus 5. We found the function based on a description. Checking on Desmos, we see that the parent function was reflected across the x-axis and then translated 5 units to the right. So we defined the function correctly. On Edpuzzle, please define the function with the following description. An absolute value function with a reflection across the x-axis, a vertical dilation of 0.2, and a translation 7 units downwards. So regardless of the type of function, a, h, and k will have the same effects. A affects the dilation and reflection. The parameter h affects the horizontal translation, and k affects the vertical translation. Great job today, and please make sure to submit your notes on Canvas.